Okay, so let's discuss what you have. Yeah, that's great.
So what I created these function like the exercise you given us to like do that. So when I'm
Yeah.
running this my code,
Yes.
so like I'm not actually to format the result output actually. So why it's like when I'm running this code on the Jupyter, like sorry, the node, what we
Yes.
call, yeah. So it's
Yes.
like I can see the structured data and everything. Okay,
Yes.
but when I'm running here, actually, it's giving me like every data is coming, and then when I'm, let's suppose something uh, Python or something.
Yeah, just run it again.
So basically, why this value is coming is not structured value is coming. This is
Yes,
my
yes. So let's go and see where are we returning the data. Let's go and see
okay
where's the data coming from. Yeah, let's look at your code.
analysis. Okay,
Yeah.
so
Yeah, yeah.
select
So
star from student and return this function
yes,
actually.
yes. So you see that when okay, so now let's go back quickly. Let's go back quickly to yeah, Jupyter. And so can you run this code now here? Let's see what happens.
Okay, okay.
Yeah, you need that function execute SQL. No, that execute SQL function has to be defined.
Yes. Okay. 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 Right. Right.
Oh, there's an import display. There's an import cell that you need to run. Just come slowly down from the top. Yeah, just run the first cell 8. Yeah, that one. Yeah. Notice quickly what I've done for you is I have those three. That display helper is some code that I've written,
Yes. Yes.
right? And that basically gives you the functions that enable you to view the output in a nice way.
Oh, this yeah, the display results and print result and execute SQL, right?
Exactly, exactly.
Yeah, so like I use this function also.
Yes,
You can see here somewhere actually this display results and rows.
yes.
I use that actually, but
Yeah,
some
but then I don't know if it's going to work properly because we don't have this function defined anywhere, right? Or you define something yourself.
yeah.
Where is this function defined display result?
Oh no. Okay. Got it. Okay,
Yes,
I
yes.
need to define this function. Okay,
So
function.
exactly, exactly. So let's go back. I'll show you in Jupyter. Now I'll show you in Jupyter. Yeah. So let's run this code now. We got the function. Run it again in Jupyter. Yeah. Cursor is not defined. Okay. So you have, yeah. If you want, you can just run all. If that, I don't know if it's set up to run all.
It's not set up actually, I believe.
Okay, okay. So that's one of the problems with the notebook, right? We run cells here and there.
Yes.
Dependency is not written. But let's work from here. Go to the first cell and run. I'll tell you which cells we need quickly. If you go to
Oh,
the first cell,
start up the page.
yeah, start of the page.
Okay.
Let's come down a little. Let's run. Yeah, cell 4 you run.
Yeah,
Uh,
this is I ran actually. Yeah.
yeah,
You
yeah. That's good. Then come down a little bit more.
then 5 I ran it. Okay.
Yeah, come down a little bit more. Yeah, this one. Run
Yeah.
cell. Yeah, this one.
Yep.
Okay, now we got an open cursor. Now just run this one right here, right? That thing that says cell 10.
Cell 10. Okay.
Yeah, run this. So you see, this was also Kiran's question. She's not here. We'll explain to her again. But this cursor dot description shows you one part of what comes back when you execute a cursor, raw, right? This is where all the column names are stored, for example.
Right, right.
Okay, now if you just create a new cell, so hit A for above, escape A or escape B,
Where?
escape B, just hit escape B.
Acha, escape B. Okay.
Yeah, escape B will give you a blank cell below.
Yeah. So I'm using a basically Alt Enter. Okay, yeah.
Yeah, so now do just do cursor
Okay.
and enter. Let's see what comes out.
Enter,
Nothing.
enter.
Yeah,
Okay.
just enter. Okay, so that's just a cursor. Um, did we do cursor dot fetch all? Cursor dot fetch all. Yeah,
Yes.
you see what comes back now in such in this execution. When you ever execute a cursor, you will get back a list of tuples,
Right. Right.
right?
Yeah.
And that list of tuples in Jupyter is automatically getting displayed for us,
Correct. Right.
right? If
Right.
you are, so you can you put a print around the cursor dot fetch all?
The print, the function actually.
Yeah, just do print. Yeah, enter. So, oops. Okay, once we fetch all, it's empty now.
Yes.
Hit execute and then fetch all again. Cursor dot execute. Run cell 10. Run cell 10 again.
Okay. Cell 10. Okay.
Yeah. So each time you execute, the cursor is empty now. We do fetch all. It will bring everything and display, right? But then it's a cursor. Once it looks through and displays, then it will be empty again. Yeah. Hit enter. Shift enter. Yeah.
Oh.
You
Okay.
see the
Okay.
print. So the print, you have to control this thing, right?
Hmm.
By raw Python, it looks kind of ugly.
Yeah, but it's like all the tuples actually like we have the same insert, doing the insert actually statement like different rows of data.
Correct. So if you want to see it in a nice way, then
Mm-hmm.
you have to write a small function, right?
Mm-hmm.
To format the information in the cursor,
Mm.
right?
Like we have a like that the already existing function that you told us the display result, right?
Correct. So you can actually go back one step to that Azure thing quickly. No, just in when you open, go back to Jupyter, go to the other tab you have open. Yeah, that one. And you
Okay.
see there's a display helper.py. Just click,
Oh,
not PyC, just Py. Oops. PyC is actually C version of it. No, yeah, .py.
.py. Yeah.
So this, I put it in a Py file because I didn't want everybody to see it. But
Mm-hmm.
it's the extra work I have done, small functions that clean up everything and display nice. Right? So
Okay.
what I've actually done is I've generated some nice HTML wrapper around the data and
Okay.
displayed in a nice way for you.
So we need to call this function, right? And like then we can.
Yeah. So you can try. I don't remember exactly right now in codeboard. I think codeboard, if you call display results in codeboard, it will
Uh-huh.
display nicely. Okay. But
Right.
you have to just basically create this file there and then import it and call it.
Okay. 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 So no problem. Let me try it, and if I'll have any
Yeah, of
any
course.
questions, yeah,
Of
then we'll
course.
discuss again.
Of course. No, but the important lesson there, Sachin, is that these kind of small functions completely make our world very nice and pretty. And
Right.
once you write them, they make everything clean, right?
Clean. Correct. So
Yeah.
these are the basically the a kind of a global function we can create, right? And we can call it anywhere in the code.
Anywhere, exactly. So I always have written code which looks like this. So,
Mm-hmm.
okay, I think Pallavi is here. Let's say hello. Hi, Pallavi. How are you? Praveen is also here.
Fine. Hi. Hi
Hi.
all.
Hi, Prinbia. Hi, Pallavi.
So, hi, Praveen. Don't know if Praveen heard us, or you must be on mute. Hi, Praveen. How are you? Praveen, can you hear us?
Hi Vijay, good morning. Yes, I can hear.
Okay, there you are.
Sorry, I'm late.
No, yes, yes. No, how? Okay, so since three, at least somebody should ping Kiran as well. But while we wait for her, how has it been? Have you had a
Uh,
chance to look at
Vijay, I
anything?
think Kiran had messaged us saying today she'll be traveling, so she doesn't know if she can join. We
Okay,
should
Yeah.
go ahead.
okay,
Yeah.
okay. So then let me ask. Let me start with Pallavi then. Pallavi, have you had a chance to look at any of the things we discussed?
Yes, I was. It was a busy week, but I got to see it like last night. I was sitting and doing some of the things.
Yes.
But sorry, I couldn't complete assignment two.
Okay.
I'll plan to do it by tomorrow.
Okay. Okay. Don't rush, but I have to ask all of you this question. Do you find the assignments useful? Is it some because I have to put a lot of work to set up all these things?
No, this is really useful. Yeah, it's a really good.
Okay.
Yeah, we are trying out, but I think we want more like some qualitative analysis from you also because I don't know about the like test may
Oh,
pass, but I'll be
about
writing
the
it
crow. Yes.
yeah, about the code. Yeah.
Yes. Of course. Of course. I really want to do this. That was what I was going to tell all of you. I really. It doesn't matter whether you get the code working or not so much, but it really matters that you sit down and you think about it and you try it, right? And then once you sit down and you think about it and you try it, then you can bring it up also, and I can also review and discuss it. The only confusion for us is if I want to discuss all the solutions, then probably I need all of you to be finished with one lab. You know what I mean? If you're still working on it, I would rather wait till everyone finishes. So don't let it lag too far behind. Then I think we'll be in good shape.
Yes, yes. We'll
So
plan
what?
to catch up.
Yeah. So if you guys, for example, tell me next time that, or if you send me an email or whatever, and tell me that you're finished with the first lab, then I can discuss the first lab.
I am actually done with lab one.
Okay.
Lab two is what is pending for me.
Okay. Good. What about the others?
Yeah, lab one is already completed. So lab two, I was having something to discuss. So that was yeah.
Okay. Okay. Praveen as well.
Yeah, I'm in lab one doing that.
Okay.
So yeah,
Uh,
sorry.
okay. So maybe next time we can look at this. Yeah.
Yes, that will help just to know whether we are following the right patterns, like what the best way of writing code in Python versus the way we are writing the code versus.
Yeah. Exactly. I think that will be helpful, right?
Right, right. Yeah.
So okay. So today I have a. So let me just organize my thoughts like that. If there is time today, I will show you a couple of things on lab one. But if there is no time today, then next time we will look at lab one and lab two together. Okay.
Okay. Yeah.
Okay. So just one quick comments now. Last time we talked about this a little bit. How do you guys feel about Python and SQL after thinking about it and after a little gap?
Still comfortable with SQL more than Python.
Okay. Which
I
which part
wanted to
of
ask, I felt like writing the queries more than getting it into a list and trying to do the function. So I don't know what should be the right way to do it, but
say
But
that again one more
what I
time?
have found actually the SQL syntax is similar to the SQL we write it actually in the database.
yeah, it is
It's
the
like
same. It is exactly
yeah,
the same, I think.
yeah,
There's hardly any difference in the SQL part of it.
right,
So
Okay.
it felt like for the lab too, there's so much temptation to actually do everything via the SQL and get the answer out and return versus get fetch all kind of a thing and
Yes.
then do the work in.
Exactly. So that's why I set up the lab this way, Pallavi. That is to force all of you to consider the two differences, right?
Mhm.
Sometimes it's easier to do everything in SQL. It feels easier at least. And the question
Because of the
is,
comfort level, yeah.
yeah. And the question is that what we want to do, right?
Mm.
So, um, so yeah, that is something we're going to continue to discuss and play with. I think that if you keep trying though, by the end of this course, you're going to find that you're going to be equally proficient in both places, right?
Mm, mm.
The important point I want to stress to you is that still, because we're doing execute command, you can just copy the SQL and put it into your Python, right? So you can get everything working pretty easily, right?
Yes.
Yes. So the
Yeah.
logic right now, okay. Okay, so let's start today. It's going to be interesting. So can all of you follow me through this path? If you go back, before I start this, did any of you try to install Python on your notebook, Python on your computers?
No, not
No.
yet.
Okay, let me know. Maybe next time we can do this. Just
Okay.
okay. Okay, so if you follow me here, that's section 3. Sorry. So if you go to the course page,
Mm-hmm.
then go to this interactive session. Oh, while we are clicking on these things, we can keep talking, right? So then this is the notebook that we want to use. How are you guys finding using the notebook and how the material is laid out? Is it easy to follow? How does it feel?
Yeah, I was doing lab one right after this week, after
Yes.
another class had been done. We had moved on to another notebook. So I was suddenly I went back to notebook one and kind of did my searches on the easy commands for list, like
Yes.
sum and sort and all that. So
Oh, okay. So just so you know as well, now I told you last time I would put it here. I didn't send an email, but here you can just go here. You don't have to do it right now. But I put a small cheat
ah,
sheet, a small
nice.
cheat sheet here. Okay, I will just open it for now. It's not very. I try to keep it very simple. So it's an interesting thing for you. If you look on the right hand side here, there's all these methods which are available on a collection. Okay, and if you kind of play with these and come back and ask me some questions if you have next time, we can discuss it.
Mm-hmm.
So
I
just
had one thing, Vijay.
yeah,
I kind of thought C dot sort, or
huh,
the list dot sort kind of it returns you another sorted list, but
huh,
that didn't happen. So my code got an error because I returned it into one list and tried to use the
yes,
median on
yes,
that, and
yes.
it kind
So
of
notice here when I have given this cheat sheet, I have made an important comment here. You see
mhm.
here, useful non-mutating methods,
Correct,
useful
correct,
mutating methods, right?
right, makes sense. Yeah,
And,
it's very
and
helpful.
yes, this becomes a theme for us going forward. Even today, you will see that we have to basically make sure that when we perform an operation on a list, whether the list itself is getting modified or a new list is getting created, right?
Correct,
So if
correct.
the list itself is getting modified, I call it a mutating method. It mutates the list itself. If it's
Hmm.
non-mutating, then it will return some kind of new object. Okay. So we continue to keep this theme. You have to ask this question all the time and know that. Okay.
Correct.
Um, okay. So if you follow me through this path, I think Prakash just joined. Yeah. Hi, Prakash.
Hi, Vijay. Hi.
Yeah. Okay. So Prakash, we're just getting started. So if you go to section 3, processing data, and then this interactive session, and just follow me from, there's a link in there.
Okay,
Yeah.
fine.
If you click on this link, it'll get you into this thing. All of you have to clone this and run it basically. Okay. So today we are in a let's get started. There's a lot of material for today. Okay. I'm going to try to present it as much as I can in an organized way. Then you'll tell me. So there's some files here, the important file here, let's start with introduction to Panda series. Let's start here, we'll cover this and then we'll go to the other one. So today's discussion is a good discussion to have after we have finished the discussion from last time, which is now that as Pallavi said earlier, we have a lot of data manipulation to do inside our programs, and we are tempted to use SQL to manipulate the data. So are there better ways to manipulate the data in our programs? And typically what we have done is we have used if statements and for loops and all kinds of things to try to massage the data. But what we are going to learn today is that, of course, the right thing to do is probably to create a better data structure and better methods, more powerful than, say, for example, lists. And see, by powerful, I mean it's more flexible and also more efficient. Okay, so that I'm going to try to tempt you, and you're going to tell me whether you're tempted or not as we go along, to use Python more and more to manipulate the data, right? So last time we did the hard part of, hey, how can I retrieve the data from a storage? We did the database thing. Again, today, if there's time towards the end, I will do that file IO thing. We have to go back and finish that part. But let me start this thing today anyway, okay? So once we get the data in our programs, let us see if there are nice ways to manipulate it, okay? Now I have to say one more thing before we jump in and get started, which is, here is at least for me, it's a kind of always a struggle, right? Which is, I'm trying to learn Python and get good at using Python. And suddenly somebody creates a library. The library has a lot of functionality in it, but in order to use the functionality, I have to do a lot of work, right? I have to learn a lot of things. I have to use a certain style of programming, etc. And that takes a lot of extra work. You can't just say, I'm a Python programmer, I learned Python, I will be able to be efficient in this new world. You have to invest time. At least it's my opinion. So as you guys are learning this, you're going to help me understand this, right? Are these things that you can just pick up easily, or does it require conscious thought? For me, it always requires conscious thought. And if I move away from this space for a little while and come back, I have to refresh my memory because there's a lot of stuff here. And if you don't do things the right way, you'll pay performance in terms of, you'll write a lot of code, and also performance in terms of, okay, I think Pallavi is having a little problem. Let's see, Pallavi, can you might have this problem which Sachin had. Sachin, does Pallavi's problem look like what you had?
I've only sent it to you actually. So I'm unable to run on free compute. I cloned and.
Okay. So there's one possibility here, which is bad, Pallavi, which is that sometimes if you left the session running, it stays a little tail in your browser. It keeps some cache and then it gets confused. Okay.
Okay.
So can you do what? You might have to take 1 minute. I won't go very far away from here, but you might have to close all your browser windows and start again.
Okay, we'll do that.
Yeah, but you may not have to. It may not close Zoom, so you should be okay, I think.
Okay.
Let me know if you're going to disappear. Maybe I'll see you disappear. Okay.
Okay. Yeah.
Yeah. So close all the browser windows, restart the browser session, and then go back here.
Okay, we'll try.
Okay. So which window are you seeing of mine right now? This one which says Pandas series. Is that what you're seeing, Sachin and so on?
Yes.
Yeah.
Yes.
Okay. So let me get started. So I'm saying this is to get full benefit of this, we have to learn this as a focused way, right? So that's what we're going to do. So let's, as I want to do in these sessions today, I want all of you to open the notebooks and start writing more code during the session. Okay. So I'm going to give you breaks and we'll see how interactive we can make it. Okay. So as always with any collection, so far we have primarily learned the list collection. Did we talk about dictionaries? Not so much, right?
No.
Okay, so let me just do a quick introduction to dictionaries. We don't need to use it heavily, but it's a very useful data structure. So let me just say, for example, whenever we have a data structure, we have to ask the question, how can I create it? So here's an example to create a dictionary, right? Just make a blank cell. So dictionary has a nice way to construct it. You can use how do you want to call this? Flower brackets or the curly brackets to create a dictionary, and you need to give it some keys and values, right? So the key could be, like for example, the key could be a number, say for example 1, and the value could be the string version of the number 1, and 2 and 2, right? So this will create a dictionary for us. Let's just make it and see what it looks like. Okay. So So, okay, so then I have to say something very important. Since today's discussion is all about data structures, each data structure has a powerful pattern encoded in it. This pattern is basically one of association, right? It says if you give me a key, I will give you the value. Whereas the list is one of ordered collection. If you give me an index, I will give you the value, right? So instead of using the index here, we're going to use the key to retrieve stuff. So you can say adict and the value 2. Okay. Now, I've only given you a very simple skeleton here, but let me ask you to discuss briefly with me. Why do you think this collection would be useful? Anyone?
Maybe table, we know the key and we can get the values.
Sorry, Prakash, just a little louder.
Maybe it is a type of table in the database, something like we know the key value, then we can get the rest of the value, something like that.
Sure. No, I'm saying that, can you give me one example, one situation where you would want this kind of associative relationship?
We want, so sometimes most of the problem we have some master table, where we have a code and their description.
Correct.
So it's stored. So like based on the code, we wanted to result as a description. So in that.
Correct. So yes, but I want all of you to understand that this normally in programming, when we want to get an associative relationship, right? If, say for example, let's do a simple example here without a dictionary, okay? So I'll give you 1 minute to think about this. I want to write a program to convert all the numbers from 1 to 100, right? 1 to 100 into its string version, right? That means for 21, I should see 21 in string form, right? 22, like you should get the string version. You know what I mean, right?
Yeah.
Like this, right? If you want to get 21 to look like this, or maybe better, let's put a space here, 21, right? How would you do this?
So this is where like you'll put it all into a dictionary 1 to 100. Whatever input you get by that person, that
Sure.
you'll use it as an index.
Yeah, so I'm going to make it a little bit more efficient than that, right? Because maybe we don't have to put all the values from 1 to 100. Of course, that is a brute force thing. But if you put all the values from 1 to 100, it's possible. But remember, there are simple rules, right?
Correct.
21 and 31 have simple ways of associating things. Okay? Maybe you can take it as a small homework and do it, okay? Next time I can review the solution with you. But anyway, Pallavi's suggestion is correct. The dictionary solves this problem without any if conditions, yeah? All you have to do is look up 21 and it'll return the corresponding string, right? So this
column
kind of
value, column and value, like, you know, a column name and value for that column can all be.
Yeah. So the idea here is a simple idea that where we were normally writing. So for example, I could have written some complicated if statement, right? If 20, blah, 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 something I could have written. Here, I just converted into a nice data structure and I'm just doing simple lookups, right? So that can make our code very, very efficient. So the long story short, using the right data structure is going to make our life terribly efficient, okay? So today we're going to unleash not dictionaries, but a different data structure. So this is called basically this is a more powerful list. And it's living in this library called Pandas, okay? So let's just start right here. So you import Pandas, and now we have to create a series, okay? So can all of you run this and look at the pattern? You basically have a constructor functions for series. You pass a list into it, and it'll create a series. So can all of you just, okay, it's going to take a second if you run it, I guess, yeah. Okay. Do all of you have this?
Yes.
So you get the series, but notice the series is already more powerful than list because it actually has an index here. Do you see this? So the series is kind of like a list, but it's actually a list with an index. And you can use the index to store the values, right? And you can use the index to retrieve the values. Make sense? So by default, it's creating an integer index. But if you want, you can specify the index. Okay. So let me. So how do I specify the index? The answer is you provide another list here. Put a comma and you say index equals, and then you can provide another index. Okay. So can I give you all the quick exercise? Can you create a new series? Let's have some index here, like first, second, third. Let's have a string index instead of 0, 1, 2. Just type, whatever, first, second, third. But you have to make it as strings. I'm just giving you some time so that you can.
Like by default, this Panda series stores this the fourth row as a display output data type as an integer. It's a by default for every list Panda series create.
For every time you create a series, it will create an index automatically for you, right?
So it's like a good combination of dictionary and list.
Yeah, so it's an index, correct. It's a good combination of dictionary and list because it's an indexed collection. So it has some flavors of dictionary, but it also behaves just like a list, right? It's just one dimension. The data itself is one dimension. So the index is like the keys of a dictionary, or it's like metadata for your data, right? So we're going to play with this, and I'm going to show you why this index can be an interesting thing to have, right?
I'm getting an error.
What kind of error?
So name 0, I gave 0, 1, 2 as the index. It says name 0 is not defined.
No, but when you type 0, if you type it like this.
Single quotes.
No, yeah. So what I'm saying is it doesn't know what 0 means. Yeah, exactly what Pallavi said. You need quotes.
Okay, string. So yeah, okay. Yeah. So I missed the string part. Sorry.
Yeah.
So I just need to give the starting point here, or I need to give the complete set?
No. So this index, when you specify the index by hand, it should match
the number of
elements,
items.
Right? Yeah. So let's see what happens if I try like this. So it says, you see, the length of past values is 3, but the index implies 1. Yes.
Yeah, I got it.
Yeah, but I'm curious now that you have made this question. So, okay, I want all of you to be in this mode with me, okay? We don't have to memorize everything. We're going to try and we're going to explore this, right? So, it is one of the nice things of programming is that you don't have to memorize, right? So, yeah, so this thing works if the length is the same. If the length is less, it doesn't work. What about if I make one extra element here? Again, yeah?
Okay.
So the index has to match. Okay. So by default, I think the default index or the integer index is probably the easiest way to create stuff. We'll go through some examples. So now that I told you there's an index and there are values, how do I pull out all the index? How do I pull out?
Nums underscore list of square bracket.
Yeah, square bracket.
First.
Yeah. If you want one value, that's correct.
Okay.
That's correct. What happened? Did I create it? No, no. Yeah. That's fine. Okay. So this is how you'll access values. Just like a dictionary, you give the key, give the index value, and it's returning. Give the index, and it's returning you the corresponding value, right? But I want all of the index values. I just want to suppose somebody created a new list, and I don't know what does the index values look like. You can say dot index, okay?
To loop through it or something like that.
No, so today's story is going to be very little loops.
Oh, okay. Direct random access. Correct.
So by the way, that's going to be I want your feedback on this, okay? Because there is a whole style of programming that we are going to explore little by little. which says that for various reasons, being more functional, using functions and getting rid of all these if statements and loops can make our code easier to understand, more declarative, like SQL if you will, and also makes it more efficient. The program underneath can be optimized a little bit better. Okay, so we'll see. Okay, so if you want all the index values, you can see it. Okay, and what about if I want the values? Then, by the way, you don't have to memorize these things. You can just hit tab here and you should see. Sometimes there may be too much here, but soon you will get used to it, right? So here's values. So if you want just the values, you can see the values. Make sense?
Yes.
Okay. So can you just practice this? Okay, so now, I'm sorry, we're going to skip over this, but I will just mention this right now. I will use it in a couple of places. I actually prepared it. And then I thought it was a little heavy because I really want to get to more interesting examples for you. So, but from a perspective of a little bit of history, let me just mention this to you. In Python, a lot of the places where Python gets its efficiency is by falling back to low-level libraries written in C. Sometimes the C can even call Fortran libraries for numerical processing. Okay, so the first effort here was to try to manage array data, one-dimensional arrays, two-dimensional arrays, for scientific data primarily, right? Integers, doubles, floats in multi-dimensional arrays, and a library called NumPy was created with the primary goal of being easy to use and the secondary or equivalently another goal of being performant. Pandas is a wrapper around NumPy, or at least it delegates a lot of its functionality, storage and retrieval functionality to NumPy. Okay, have any of you used NumPy before?
No.
No. So we will skip it for today. Okay, but if there's time at the end, I will bring it back. For now, it just, all this example is showing here is that you can go to NumPy and you can basically create a series from it. So let's skip over that one. Now let's go to the one that's interesting to us. So here, just now we introduced the notion of a dictionary. So here is a dictionary. Again, it's associative. It's connecting the values 1 million to its numerical representation, for example. And I want to create a dictionary from it, sorry, a series from it. And Pandas says, oh, if it's associative, I will use the keys as my index and I'll use the values as my values. So if you have any valid dictionary, you can just pass it to Pandas series and it will convert it into a series. Okay. So can all of you create the series, and can you make sure you can display, for example, 3 million? Can we display 3 million using the bracket or the index operator?
Yeah.
So very quickly, what are you guys seeing right now? You're still seeing my screen, right?
Yeah.
Are you all able to get out of something? You have to tell me when you're done.
Not yet.
Not yet. Okay. Or ask me some question if you need.
So it will be S1 and square bracket 3 million, right?
Correct.
I'm getting some. Oh, I'm getting S1 is not defined. Okay, because I didn't run this. Okay.
You have to run the cell. Yes. By the way, as you're working in Jupyter Notebooks, notice this thing. Every time I run the cell, it's got to update. It's going to update the values, right? So here's a good example. If I go here and if I say, let me try this quickly. If I go here and if I go to this cell and if I say S1 bracket and I put in my 3 million and I try to run this cell, I will definitely get an error, I think, unless I ran okay, I ran this one. But the point is, if you look at these numbers here, this is 16, right? This is 15. So this was run before this one. It's useful to see the numbers and know the order of dependency, right? For example, if I change this, let's change this to 3 million, and then I'm expecting to see 3 million here to be able to use it, and it's going to give me some error. And I'm like, why? I see 3 million on my screen here. Why it's not working, right? And you have to get used in Jupyter notebooks to recognize immediately, this is 17, this is 15, right? And if I change this, it should be updated, right? So if I update this now, this will become 18. So now this has been run after this cell. So now I run this will become 19 and the order is good, yeah? So use these numbers to guide you if something's getting stale, okay? This is a problem in the Jupyter notebook. In general, you should always go incrementally, but once in a way we go back and we make some changes, then we should remember if this is stale or not, right? So,
okay.
Yeah. So is everybody got this working now?
Yes.
Okay. Yeah. So far so good, right? So it behaves like a sensible thing. So now the next thing is slices, right? Are you all experts in slices now? Or lists?
Not yet.
What do you think about slices?
It's quite helpful when it comes to strings. I don't know about normal arrays.
No, just a list, for example. So let's do a quick toy problem with a list, okay? So all of you can create a list quickly. I like this trick. So let's create a list with 10 elements in it, right? And then let's display it. Okay, so we got 10 elements. Now, quick question to you. I want to extract only the elements from 3 to 7. How would you do this if you don't use slices?
We'll have to index it and join it, concatenate it.
Okay, so you want to tell me what that code looks like?
I have to be D underscore list, like, okay, B underscore list or something.
Okay, you want me to create a blank list?
B underscore list is equal to like A underscore list of 2 comma A underscore list of 3 A underscore list of 4.
Oh, you mean you're going to do this? Oh my goodness. That's not even programmatic, right? So you're saying you'll do this, right? If I understand correctly.
Yeah.
Okay, how many of you are looking and holding your head like it's going to hurt? Does your head hurt when you see Pallavi doing this or no? Or when you see me typing because of her instructions this way?
I'm so bad at optimizing code. Okay.
Okay. So give me your impression. What happens in your mind when you see this? Prakash?
It should work actually, I think so. Because it's a
No, it should work. But what is going on in your head when you see this kind of code?
The good part is I am on par with my teammates here.
But okay, I'm sorry to say, but if I was your manager and I see code like this, I'm going to come and ask you, like, what is going on here?
Okay. We can do like in looping it through 3 to 7.
Okay, it's getting better now. Code is going down some journey. Okay, so okay, Pallavi. So now let's go through. So, but wait, before we go to loops, what is the biggest problem with this thing? The two problems, right? One is it's completely unclear what the meaning of this code is, right? You have to stare at it for a minute and then you have to understand, oh, Pallavi is actually trying to get the second, third, and fourth element out of the list. it takes a second for us and put it in a new list. It takes a second to understand what's going on. Number two, if I came back and said, I want also the fifth element, you have to modify this and you have to go into the list and do some physical changes, right? It's not very clear what the parameters are, right? Okay, so now, Pallavi, can we do better than this? So you're saying we'll do a for loop, yeah? So first try. I like this code though, first try. So now second try. What do you want to do?
Do I need to embarrass myself or can Sachin?
Oh, no, oh, please, don't consider it embarrassment. Just consider it a conversation, right? We're just trying, it's not an evaluation of you. So I'm sorry if I...
No, I'm just kidding with it, just kidding.
Yeah, I'm saying that. This is how we learn, right? But trying to do something, there's no point in this conversation where I'm thinking, oh my God, Pallavi is not a clever person, or I'm not drawing any conclusions about you. I hope nobody in the class is doing it. We're just trying, right? We're just trying, and then we can get better. We try something, because I am also trying to understand how you're thinking, so that I can shape the way you're thinking, right? Only if you show me, I can tell. Okay, there's nothing wrong. This code works, so that's better than nothing, right? Better than saying, oh, I have no ideas. So I would actually appreciate your skill for coming up with something, and say Pallavi is a student because she's responding and doing something, right? So how do we say there's like a student who just sits there and does nothing? This is a very difficult challenge for me, right? The one who's interacting and trying to get better is the best top student for me. I don't need anything else, right?
Yeah.
Yes, I don't need anything else. If you're trying, that's all we need, right? Okay. So, but so do you want to try, or you want me to just do something?
Like we have to do something like b_list dot extend or append and keep adding the.
Yeah, so you can start with a blank list, right? And then you can do some for loop for I in. Okay, at least we have this nice powerful thing called range, right? So range will start from 2, right, and go up to, you have to put 5. Remember, always you have to go one more than range, and then you can add to list, right? You can do b_list. By the way, if you haven't used this plus equals, you can even use this, and then you can do something like this, right? And if everything is good, then we can view it. It is not iterable. What did I do? Of course.
Oh, yeah. Okay. Not so I, right?
Huh?
Is it B?
b_list. Yeah, it should be.
It have to be. It will have to be like starting from 0, right?
Okay, so let's do append. Okay. So this also works, right? But now I'm saying consider this, and then you're going to tell me which kind of code you like. I say b_list. I say I want all elements which start from 2 and ends at 4. I have to always specify one more than the value that I'm interested in. So 2:5. Oops, sorry. So 2 starts from
a_list. You have to do a_list.
Yeah, a_list. Right? So do you see the power of this now? So in the beginning, for all of you, you should feel like, why am I going to do this, right? Because you're coming from a language which doesn't support this. But once you see slices, it's kind of a Python idiom, right? There's no way you would see good Python programmers writing this kind of code if they can write this kind of code. But that is a Python programmer. So now let me ask you guys, which kind of code are you wanting to write? Obviously the bottom one?
Yes.
Yes. I mean, I don't want to push it too hard and say that you should feel it's a little strange, it's a little different, because I felt it too at some point, right? The only thing I'm trying to push you is to see the elegance of it and then recognize that something with practice will become second nature for us and then start using it, right? And that will make our code much more cleaner, compact, nicer, blah, blah, blah. Okay? So I think I've beaten slices to death. Any question on slices so we can go on?
So this is only thing one dimensional, right? The list is refers to one
Yes,
dimensional.
list is one dimensional. I'm going to show you what happens for multi-dimensional stuff too. Okay? But right now we are still working with series objects. So let us go with series objects and see if slices work with series, right? So we created S1. So first of all, integers, well, first of all, let's get some value from S1. So if I do S1, 1, so this is an amazing thing. Already you see this thing here. When we created this Pandas series, index is some 1 million, 2 million, 3 million is my index. I still have access to integer index. Make sense?
Mm-hmm.
Sometimes it's easier for me to get the values by integer location. First element, second element, 1, 2, 3, 4, 5. Sometimes I want to use the index value, which is different than 1, 2, 3, 4, 5. Both of them are going to work. So let's try this again. So can you replace 1? Can all of you try? Replace 1 with 3 million and see what happens. In the same bracket.
So it will give you the value, this 3 million.
So that's very cool, right? So this is a kind of overloaded behavior. The bracket operator is actually kind of being intelligent. It's saying, hey, if you give me something to look up, if you give me an integer, I will try to use the integer index. If you give me a key, then I will use a key to get the value. The index, by key, I mean the index value. Okay, and if you give me something that's not in the index, then I should give you an error. Let's see. And it'll say an error. Unfortunately, the errors are long, but at the end of the day, it says there's a key error. Right? And then you should know that I made a mistake with the key. Okay? Okay, so this seems to work. Any comments or questions?
No.
Okay. So I'm going to just introduce one thing. I don't know if I need it right now, but we're going to use it heavily later on. So because this index operator has two ways of accessing stuff.
So one question.
You want to be explicit which way you want to access stuff. There is this method here. You can say s1.lock. And then here, so integer, if I want to use integer index, I keep mixing, yeah. If I want to use the integer index, I do this, when I put the bracket, I say ilock. So that means use the integer index, okay? And then if I want to use the index itself, I just do s1.lock and use 3 million. So what is the difference between this and what we wrote before? In what we wrote before, we did not instruct Pandas explicitly whether to use the index or the integer. Yes? You see what I mean? It's the same code except I inserted this extra ilock and lock. Okay, lock says please use the index. I'm going to give you a value, it's a key in the index. Please use the index explicitly. And ilock says I'm going to give you an integer location, right? So give you an integer and you have to use my integer to find a value. Whereas here, it did the same thing, but we didn't have to specify it. Right? We rely on Pandas to do the right thing.
We have a different set of integer indexes that we have specified, and it doesn't, like, if you want to use that to retrieve a value, like suppose your your series has 2, 4, 6, 8 as the indices, whereas the actual index will go 0, 1, 2, 3 kind of a thing, and you want it to differentiate and get it. 2 can mean either number 3 value or the first value.
Yes. So what I'm saying is, for today at least, because there are many detailed and complex paths that we can go down here. But today, at least, I would say the following. The index is completely controlled by you, right? You can give any kind of sequence here you want. You can give 2468 or 10, 20, 30 or 1 million, 2 million, whatever you want to put for the index, you can put whatever you want. For the default index, which is a sequence, it's always better it starts with 0 and goes to n minus 1, really, right? Follow the Python convention. Can you start that index at a different value? Can you make it jump around? Maybe, but why would we do this? Yes? Does that make sense, Pallavi?
Yes, yes.
Yes. So index
Am
you
I
should...
saying that the use of that iloc will be when you have other integer indices that self-defined by you, and you don't want it to confuse between the auto-assigned index versus what you are.
Correct. So, but all I'm saying is the index that we assign does not have to be integer at all. Yes.
Yeah, that is
So
correct.
the idea is that Pandas is saying for any series there are going to be two indexes, right? One is an God-given index or sensible index, which is like a sequence counter, right? It's like auto increment. When you insert in a SQL table, it's just going to keep incrementing by 1. But the actual key is a completely different animal, right? This index that we specify by hand that we are responsible for maintaining, right? That is like a compound key or a complex key. In this case, it's still one-dimensional, but it's a key that I'm assigning.
And one question is series like tuple, like you can have different data types and all that?
Of course.
Okay.
So data types. Okay, so I'm going to give some examples soon in a minute. But since you asked the question, I will say yes. So of course, the right-hand side of the index, the right-hand side of our series or the dictionary could be any data type, right? Integer, float. It could even be nested something, right? It could be another tuple if you want it. So it could be any kind of Python structure. The left-hand side, the index should be a value type. So you're going to use sensible value types, okay?
So is there any performance or best practice that you should use integer index, or you can use something like that?
One more time, Prakash, just a little louder.
So is there any best practice for this kind of series?
So the best practice is the one I'm going to ask all of you to reflect on and develop this intuition. The index is something that you want to create that is decided by the problem you're trying to solve, right? That makes it helpful for us to look at the data in an intelligent way. It depends on our retrieval patterns, how I want to store and retrieve data, okay? So in fact, because I did this theoretically, it's kind of abstract. So let's go and do something concrete. So here's your exercise. Can you look at this data now? Ask me a question. I want you to create a series from this. So you want to look at the data, you want to understand it, you want to tell me what shall be the index, etc. You can even create first something without specifying the index. Why don't you start there? As soon as you've done it, will you tell me?
So data is actually like a dictionary.
Correct.
And cities is like a list.
Correct.
Okay. What are we supposed to do?
You're supposed to create a series for me. Here, cities data, right? So I can even do the starting, we'll say pandas.series. Now what will we do here? What do you want to do? So we would like to load all this data into that series, right? Not just the city names. By the way, the number on the right hand side is the population.
So we can get like assign the population for every city, like NY city, and for this 85 million for the NY city.
Yes. So how are we going to initialize? How are we going to create this series? What will we put into this parenthesis?
Data.
Yeah, just data, right? So that's the simplest thing to start off with. So let's just print it out and see what it looks like. Let's see what got created by default. So what created by default is actually interesting, right? And it's kind of indirectly an answer to Prakash's question. Pandas was trying to be smart and says, Prakash, I think you gave me a dictionary. So I'm going to take the keys in the dictionary and use it as my index. Right? From the dictionary that you gave me, I'm going to just use that as a key. Make sense? So I didn't even have to specify the index. Okay? But if I wanted to be clever and I wanted to do something different, I could specify the index. So I can say index equals, and let me try this and see what happens. Cities. Because I have a list of cities. Okay?
But
So
the
now
numbers don't match.
yeah, number doesn't match, and Python says
Wow.
it's even clever, right? It says I'm going to try to help you, but I'm going to put a blank in there for you.
Ah.
Okay?
But
what
it failed. It failed earlier when we were giving different numbers of index.
So we're gonna go back. You're gonna go back and check what happened there. Okay?
Okay.
Yeah. I have to reproduce that failure too. I don't remember exactly. Okay, so just try it again, Pallavi, and let's see what happens. Okay, keep this example in mind and try that again.
Okay, will do.
So what have we got? So we got something very cool here. But before I go here further, let me now ask the question. So if I want to get, suppose now let's you see what we can do with. Did I do? Yeah. So how can I get the first and second elements? Let's say. Oh, first let's get the first element. So how will I get the first element?
Cities underscore data of 0.
Yeah. So you see why the integer thing is nice, right? So that is nice. What about if I want to get the first and second element, or first, second, and third element?
0 colon 2.
2, yeah. So
Oh,
that's it.
3.
Right? So you're becoming an expert on slicing now. Okay.
3. Okay.
3. Okay. Okay. So sorry. So is everyone starting to see that these integer indexes can be useful? Okay. But what about if I wanted to slice with the keys? What if I want to say, okay, so let's try now retrieving data using the keys. Okay. So let's say New York City. So this should work if I type correctly.
Capital Y.
Type correctly. So this should work. What if I try to slice here? Will it work?
I guess it will.
What if I put it in a wrong way?
What is wrong way?
Order.
Like I put Buffalo first and New York City and all that.
So that is a little bit of Pandas magic, yeah?
Nice.
Okay, now you see why the slices are even more friendly. You don't have to think too much. But one thing I will tell you, it's using the same order in which the index was created, yes? So if you're looking for slices, that's how it's working. Notice also one more strange thing. This is slightly bad according to me, but okay, I can see why it makes sense. Here, the stop value is included.
Yeah.
Okay. So, I don't know.
But that's also because like 0 is also included and like.
Yeah, but in the other case, the stop value is not included.
Correct. Yeah.
Okay.
That is more like the number I want more than it's actually that kind, right? The
Correct.
way we put range of 10, I need 10 numbers. It starts from 0, ends at 9.
Correct. So let's just talk about this quickly again. In A list, when I say 0, 0,5. Sorry, 0,5. If I take a slice of, as Pallavi was saying here, if I take 0:5, I get 5 elements. So the 5 actually helps me know that I get 5 elements. It's just the index location 5 is not included because I go up to 4. I already got 5 elements. There's also one more benefit here. If I want to, for some reason, if I want to create 2 lists, and now here I want to start from the next element, then here I say 5 to whatever, to the end of the list. So you see that here I don't have to skip over. I can specify the continuous value from here. And there's no duplication. There's no repetition because this fellow, the edges are not overlapping. You see what I mean?
Yes.
So these ranges
So if I have to get from starting from 5, I want to get two values. Should I specify 5 is to 8 or I have to specify 5 is to 2?
5 is to 8. 5 is to 8.
Oh, okay.
Yeah. So the slice is always the start index and the stop index. Stop
Stop
index
index minus 1 plus
plus 1
1.
minus 1. Yeah. Yeah. Okay. Makes sense?
Okay. Yeah.
So that's why the index is always, when you do slices, you always get the stop index minus 1 as the last value retrieved. Right? For these kind of reasons. The only thing is when you do slices with the keys, you're going to get everything that's specified in a slice. Okay. Okay. So we have created series. We have set up stuff. Prakash, did this answer your question about what kind of index I will create?
Yeah.
So you see in this example, because I'm working with population data, it makes sense to have the city name as the index, right? Because I will probably want to look up the population by the name of the city.
Yeah.
And you always get a free integer index. So if you just wanted, do some integer manipulation, you can always do 1, 2, 3, 4, 5.
Mm-hmm.
Okay.
So we
Okay.
actually like change the order of the city in the series.
Where?
So the cities data, this
While
47.
slicing, he's
Yeah.
saying.
Okay. Can somebody memorize what is for New York City? 85,000. Okay. I changed the order. Okay, so does this look something I'm trying? Okay, let's see what happens. How does it look?
Wow.
Pallavi said, wow. So what did you see, Pallavi?
Like it just reordered as per the index.
Correct. But it
But the
didn't
values
look up.
Yeah, it did. Like
Right? It actually went and found where's the New York City data and put it in the right place.
Correct.
Right? It didn't just take the list and just paste it on top of my data. Right?
Hmm.
And that's why when it didn't find something for Rochester, it put NAN here, right?
But
So this
what is this? The new thing I think you in Jupyter it's got added the D type.
D type is the data type for every series will tell you what is the data type of the values in the series.
Oh, that's
Okay?
like a panda thing, is it?
It's a pandas thing. It's telling you how it's storing the values.
Okay,
Okay,
but you said it could be different values, right? Need not be the same. Like what if I have a mixture of values?
Then it'll make it into an object.
Vijay,
Okay.
when you were using only series data, not index, it was giving in the integer. But when you use index, it showed in float.
So that is another thing. So pandas, okay, so this is very important. We will cover this a little bit later maybe. Pandas is trying to be friendly to you, right? It's saying I'm going to look at the data and I'm going to try to figure out what is the best data type to give for the data, right? And it's figuring out right now that it wants to use float. Okay, if you don't want it to be float and you want it to be integer, we have to cast this data and say, pandas, please use integers only. And there's a function called as type. Okay, and as type will allow us to change it from float to integer. Okay, there's also some stuff on initialization where we can say what to do. Okay, but I want to keep away from typing for now. Okay. But yes, the answer is yes, we can manage it however we want. Okay. Okay. So now let me get to the painful thing or the interesting thing. How will you find which values are null and which values are not null? This is a big problem in all our data stuff. So before I go further, to capitalize on what Pallavi said, what do you think about this capability of looking up and making all this, doing all this work for us behind the scenes? Can you imagine if I had to set up this thing by hand, what would take?
Yeah, it would take a lot of coding.
Yeah, we have to match and see if it
effort.
Yeah, so this is the start of our journey today, right? How we do these things. It's going to be quick and efficient, and then how do we manage all this without writing too much of logic code? So the next thing is, of course, if there is, usually we're going to find this, if there is a blank value, then how are we going to find the blank value? Or how are we going to know if there is blank values? Okay. So for that, there is an is null function. So how would you use this is null function? You just go cities data, and then you say dot is, just say dot is null. Okay, let's see what happens. So what happened?
Okay. For each of the index, you got bool
Boolean,
whether
right? It tells which one. So the only one that is true is the one that is null. Okay.
And how do I loop through this? Like how to find out?
Pallavi, today my whole job is to keep telling you don't loop. Okay.
Okay, but this is because it's coming. Like if I want to use this in code now, like
No,
how
I'm
do?
going to, of course, I'm going to show you. I'm going to show you.
Okay,
Please ask that question. Okay. I really like that question very much. But I'm already warning you today. You keep on asking this question. Please keep on asking me this question. And I'm going to
Okay.
keep on trying not tell you no loops. Right?
Okay.
No loops. Okay. So let me see if I succeed. You have to try to make me fail. Okay. So how does it work? So the question which we want, which Pallavi was trying to get to, is the right question. Suppose I want to just extract only the value that is NaN, right? Then I want to fix it or do something with it. Is that a valid question, Pallavi? Something like this in your mind?
Yes, correct. Yeah.
Okay. See, I'm even reading your mind right now. Okay, so let's see what we can do. So Panda says, hey, that I know Pallavi will come with this question. So you create this Boolean array. Okay, and you use the Boolean array as a index to the series. Okay, what should happen if I try to do this?
Hmm.
Can I not just pass parameter to is null and as true and it will print everything?
Say that again.
So cities.data is null within brackets. If I pass true as the value, will it not just print only those records?
No, I don't want to do this. So imagine that I have a big array and in various places there are nulls, right? I want to pull out only those values that are nulls. Okay.
So here in this is null is showing everything, right? Wherever it is.
Now what I did is I took that Boolean array and I passed it as an argument to the bracket operator, right? I gave it inside the index operator.
Is it like it's a two-dimensional array, right? It's not like a.
No, it's a one-dimensional array. So what I'm saying is inside here I basically put all this false, true. Okay. But let me tell the answer. I was trying to see. So the answer
it will give you the value for the roster, actually the true value.
Only where it's true, it's going to return me.
Yes. Yeah.
Right? So let's run this and see what happens. You got the NaN value. Do you see what I mean? What do you think, Pallavi? This is cool or what? You have to write for loop or this is better?
No, this is super.
Yes. So this is the story, right? Just to convince you that this is going to work, let's do some other city here. Buffalo.
Again?
Okay. Huh?
Buffalo is already there.
Oh, it's there. Sorry. What do I need then?
Corning.
Okay, Corning. Okay. So if I put here, I should get one more NaN, yes?
Yes.
Sorry. Okay, so I got one more NaN and the location is somewhere else, right? So now if I do this, I should get two cities and I do.
Okay.
Okay. By the way, this is a very powerful pattern, right? So I want to stress this pattern is very important and, it takes a minute to get used to, but I think it's quite powerful, right? By the way, these patterns now become something we got to learn, right? So for example, if I take cities data.isNull, and if I do, for example, if I want to just count how many are there, let's see what happens if I sum this. What do you think should happen?
2.
2. So you see how our code is becoming different now.
And we can also do like dot length or something.
Dot length of what though?
The Boolean array.
The Boolean array will contain everything,
Okay,
right?
okay.
Yeah,
Correct, yeah, okay.
yeah. So,
So
so,
here,
so, huh?
so when you, we just correct me if I'm wrong. So when we are using square brackets, it gives it understands at the index, right? That this is
Correct,
at this index.
correct.
But so
And
this,
this,
yeah,
yeah,
go ahead.
sorry, Prakash. Yes. So finish your question. Let me hear.
So we have defined the index as a string, and when we are using isNull function, so this is using isNull as index. I mean, it internally creates a Boolean index and then finds out.
Correct. This is called, not that it creates a Boolean index. It's called Boolean indexing,
Okay.
right? That means if you put in any index with the right length, any vector, any list with the right length, and we have trues and falses in certain locations, then wherever it's true, it's going to pull out only those values.
Okay.
It's like think of it like a mask with holes cut out. Wherever it's true, there's a hole, right? So it's going to put the mask on top of the data, and wherever the value is true, it's going to come through to us.
IP address gate, that gateway thing kind of a
Yeah,
thing.
right.
And if
So
I want to know which integer index these places are, then can I find out those integer index also
the integer index of which one?
for
The
the
true values.
true values? That's Corning and Roster. These are in third place and fifth place, right?
Yes.
So can we do that also? Is that
Yes. I have to think for a minute. Okay.
No, I think it's more like, if is there a way to, say cities underscore data Rochester, and like w- which index is that, like dot index or something like that, dot iloc, I don't know, to
Yeah.
get
Yeah.
the integer part of it. Yeah.
Yes. So there's a whole bunch of functions here. I cannot say I remember all of them. So I have to sit down for a minute and clear my head. Uh, okay, is and a is just telling me which ones are true and false. So if I want these indexes, I have to check what's the smartest way. So if you remind me next time, I will show it to you. Okay.
yeah?
Yeah.
So,
So that is part of my learning and your learning, right? Just looking through, and because I never wanted the index, because I was always using these Boolean arrays to get my stuff out. But if you want the index, there should be a quick way. And it's also a nice general Python programming question. If I have a Boolean index, if I have a Boolean list with trues and falses in them, can I convert them to integers quickly? Okay, if I sit down quietly for a minute, I will get it. Okay, so
yeah.
okay, so let's keep going now. So now we got this guy, right? So now the next question is, how do I want to fix this problem? Okay, so there are some nice things I can do. For example, I can say fill NA, and I can set a default value, right? The easy thing to do here, I could just set all the NAs. I don't want to do NAs. By the way, notice that this guy is going to be clever, even though there are NAs. So let me just show you one example. Even though there are NAs, if I sum the population, right? So if I do sum cities data, okay, if there are NAs and I sum the city data, it says there's an NAN, right? So that means I have to take out the NAs from here. So I can just say, so I can just say this, drop NA. Okay, so then it's going to create me a list which has no NAs in it, and now I should be able to sum it. Okay, so there's a lot of these small helper functions. If you really want, I can make a small cheat sheet for you. But what is most important is what Prakash did earlier. Make up a pattern that you want to implement. Ask a good logical question. I would like to sum the values even though there are no NAs in it, right? Or I would like to get the indexes of the true of the missing values. All these kind of questions. Formulate the question, then we can find the answer quickly. Okay. Okay. So Does fill NA make sense?
Yeah.
You will have fill null also similarly.
Yes. Yes.
Okay.
Okay. So now before I go further, I don't know, Pallavi. We have to check it. I don't think there's a fill null. I think it's called fill NA.
Okay. What is the difference between NA and null?
No difference.
Okay. Okay.
NA is a special kind of null, right?
Okay. It's like an integer null or number null.
No, it's not a number. Yeah, that's all it's saying, right?
Mm.
Okay, so let me just show you this thing. We talked about this, right? It was floats before. I said if you want to make it an integer, you can make it an integer. So you just do as type int like this, and it should, oops, it's going to fail now because it has NAs, yeah? So it cannot convert NAs. So we have to do cities. Okay, so let me do the fill NA to 0 right now. And now I can convert it. And you see that D type is now int64. Did you see this? I think Prakash had this question earlier, yeah?
Yes.
Yeah. So you see, we can actually convert the float to integers. You just use one casting function or one conversion function. Tell what type I want it to go to, and it'll try. If it's not possible, like we got this array where when there were NAs in there, it gives some error in conversion. Okay. Now we can say this as well. I showed you this, how to delete the missing values. You say drop NA. But I want you to understand something very interesting. So can all of you try this? After you do cities data dot drop NA, you see something like this. What will happen if I print out cities data after this? Can you try and tell me what will happen?
Okay. Whether it's mutating or not mutating.
Yeah, there you go.
Okay.
Everybody got the question, right? Sachin, you got my question, yes?
Yes.
So you're going to create it, at least if you create this one with just one NA in it, then you should have everything to do this, right? Just you have to say drop NA and then
Oh, it's just the same. NaN is still there. It's not
correct.
mutating.
Correct. It's not mutating, right?
Hmm.
It's not mutating. So if you really want it, if you want to create something without it, you can say whatever you want to give it a name, right?
New name. Yeah.
Yeah, and then just you have to assign it basically, right? And now if you say cities data good, then it's going to have the values in. Okay, so if you want to store it, you should store it. Okay. Now there is I think there's a keyword here. I have to get it right. There is a keyword here which says in place equals true. Okay. So I think it's in.
That will like self-assign the value.
Yeah, it will. I forget now the syntax here. Okay, so I have to check. I will use this anyway in. Yeah. So in place equals true will fix it right there. Okay, so we can say drop NA in place equals true, and then if you print out cities data, then it will change it. Okay, so we have to be extremely alert about this, because if you drop something, then it's gone forever, right, from our program. So mutation, okay, so this can be a long lecture. We can just spend a whole hour talking about mutating things. Mutation is a source of many, many bugs in our programs. So try not to mutate things. Is probably a good idea. Okay, so when you find yourself mutating things, pause and ask, do I really need to mutate it? Okay, does it make sense? Yeah. Mutation has many problems. Apart from bugs, it's also performance wasteful, right? Because you're making copies and deleting things and so on. Okay. Okay, so far so good?
Yeah.
A quick question, how do series feel so far? Interesting data structure or what? It's like, oh my God, why do I have to learn this?
Yeah, this is interesting.
Interesting.
Okay.
It
You,
is
huh?
like I just feel is it something that we can get JSON data into
Of course, of course, of course. I'm coming there. We're going there. Yes. So I'm building up to it. But okay, I haven't shown you the full power of this, right? The full power of this is, for example, let me not drop NA right now. Okay. So, or whatever. So if I want to do a computation, for example, I want to calculate the mean population. You see, if I say cities data.mean, it's going to completely compute it for us. Okay, and let me just, you can all of you can look at this code here. What is this code doing?
it is getting the cities underscore data divided by cities underscore data dot sum percentage.
Yeah, it's getting the percentage of the total, right?
Wow.
Now you tell me, if you have to get percentage, I have students, let's say those are student grades and I want to get some percentage or something or whatever, some quantity that I want to sum up the total values in the array and then divide everything by that. How does this code look compared to the for loop?
Oh, so much less.
So
But can we do this with list as well? Like I'm just trying. Or is it only the Panda series?
huh?
Can we do this with a list as well? Like I take a list and find out kind of percentage
So
of.
this part is a kind of NumPy feature, right?
Okay, okay.
That dividing. So here is an interesting thing, right? So for example, okay, so let me do a simple example for all of you. Did I ask you to compute some kind of statistics in the
Yeah,
lab?
it was lab one third question.
Okay, so let me just make a fake example like that, right? So if I have a list and it's a list of range, I don't know, 100, let's say, right? I have 100 elements. I want to calculate, for example, I want to calculate the mean,
Mm-hmm.
right? So how would you calculate the mean?
So
A underscore list dot mean.
Say
no,
that
no,
again.
no. So sum of all the elements in A underscore list, like sum of A underscore list
Sorry,
divided by.
what did you say no to?
No, he's using dot
I'm
me.
using the functions. Pandas use functions.
Okay, so no for loops, right?
You need to check his lab, okay? He must have directly imported statistics and
There's nothing wrong with importing statistics, but of course, so what would you do, Pallavi? You want to do a for loop or what?
yeah. So sum of A underscore list divided by length of A underscore list.
Yeah, that's it, right?
Yeah.
That's the mean.
Yeah.
So who wants to use statistics and who wants to do this?
Same difference.
Same difference. No, but I'm saying that of course you should always use, I would say, as a good practice, always if there's a stats library, always use the stats library. Nothing wrong. Right now, because we are learning Python, we want to do it in Python ourselves. Mean, median, mode, standard deviation. We should not calculate by hand ourselves. Always we should give it to a library. But what I want you to understand is this Python pattern here is very powerful, right? It's taking something normally you could have kept a value, you could have kept adding everything to that value to calculate the sum of a list, and then you calculate the length of a list. Again, in C and all we used to do, we didn't have length functions, so you have to do for looping over and all these kind of ideas. This all becomes very clean here like this, right? So we are in this path of thinking like this, okay? The only point I wanted to say here is notice that these are just two numbers that are divided, one number divided by another number. Python
Correct.
can do
Whereas
that.
the one on the above is like a each member of the series is getting divided by the
Correct.
sum
If you
of
try to
the.
do this, yeah, if you try to divide every member by this, it's not working, right?
Correct. Yeah.
So this is what we want to do, this is not working. But Pandas and NumPy were designed to do this.
Okay.
And they will do it for you, right? So now we come to some interesting things here. The one of the purposes of getting all this data into a series was so that we can do these kind of calculations on the series very quickly, nicely. Okay. So here's a small exercise for you, or we can do it together. Okay. So notice here. Okay. So let me give the problem. Then all of you tell me how many seconds and minutes it's going to take to do it. So here's a bunch of heights.
Mm-hmm.
They're all in feet. Here's a bunch of weights. They're all in pounds. Then I have a formula here. It's the body mass index.
Mm-hmm.
Okay, 703 multiplied by weight in pounds divided by height in inches squared. So you have to convert the height to inches and then you have to square it, divide it, multiply it. So how does this code look in your head? Don't look at anything on the notebook. How does this code look in your head? How many for loops you see, Pallavi?
Nested.
Nested for loops, okay? So our job today is not to do all that stuff, right? So I'm going to show you how does this work in this new world. First of all, I wrote some code. You can go away and think about it, okay? This is why I said sometimes it's nice if I can show you some code. I have to convert this. Notice I have to convert this to inches. So what is the conversion for feet to inches?
Multiply by 12.
Okay.
Oh,
So,
sorry. Divide by 12. Feet to inches. Yeah.
Multiply by.
Multiply 12.
Multiple by 12. 1 feet is equals to 12 inches.
Okay,
Yeah,
okay. But I did it even more clever way, okay? I just want to show you how powerful this can be. So I want to take just the 5 part of this fraction and multiply by 12, okay? So notice I took heights and I divided by 1. That double slash is actually integer division.
Mm-hmm.
So you can let's just try this out, okay? So you can see that this code can become very powerful. It doesn't have to be this way, okay? But I want you to play with this kind of ideas. So you can take this and look at what happens when I do this. Oops. I have to make it into a series.
Convert
Okay?
into series, yeah. So another series of.
So look at this. It gave me all the integer parts.
Nice.
See how my calculation can become very, very, very compact if I can think about it the right way, right? Then I multiplied by 12 and then I took the remainder. So I want to take the remainder. So I did heights minus. So look at this. If I want just the decimal part, okay, whatever. You can do it any way you like. I'm just doing it backwards. Okay, so. Right, so you can subtract out. I'm just showing you that various things are possible, right?
Very powerful.
Oops. Right, I got the integer part, the decimal parts. Okay, and then I can just add these two together. Notice in one line I was able to do all this stuff, right? It's not needed, this thing. You can just multiply by 12, okay? But I just want to show you all these kind of clever ideas, right? Now, the next thing is I have to square this, okay? So that means what? I have to go through each element in this series and square it. How does that code look, Pallavi? Okay, so I won't write that code, right? But you understand, you write a for loop or you write a list comprehension, you have to square all the values, add it to the list, blah, blah, blah. You do something like this. Here, it's very cool. So first of all, I have to introduce you to a new idea. Did we talk about lambdas at all?
No.
So normally what we have to do is, this is a very powerful idea as well. Normally, to compute the square of something, I need a function, first of all. Def sqr, and take n and return n squared, okay? So this is a square function. So now I can pass, so let me just take this out. Sorry. So I want to basically transform the data, but I want to transform it using a function. So notice how powerful this is. I can pass any function to this map thing, and it should.
You're not written.
I did not do it. Okay, I didn't define this. Okay. So, okay, I need to see this. So notice I'm able to square it. Okay, so this is now another very important technique in functional programming. It's called higher order functions. Why is it a higher order function? Because the function map takes as a parameter another function, right? Very, very important idea. It changes the way we look at programs. Normally we send data to functions, yes? Usually the parameters in a function are data, some kind of data to a function. For example, this function, the data we are sending is a value n, and we're saying, can you please do something to my data? In this function, we are sending a function to another function and say, can you please run my function for me? Make sense?
Yeah.
Very, very powerful idea. Once we get into this idea, it's very powerful. The beautiful thing in Python is you don't have to do function pointer and all that. You just pass the name and it works beautifully. Make sense?
Okay.
What if there is like same named like variable or something like that? That is a different thing, right? That will be handled normally. That you cannot like a same name of function, and because here there is no
Yeah, yeah.
overloading or
So,
anything like
no,
that.
of course, but you have to tell me what is the rule. If I write SQR equals 2, what do you think will happen now? When if I do this and I pass here, what will happen?
This will error out, right? SQL is
More than error, what is SQR represent in this line?
it is
Function. It's not a function.
I know. Why is it not a function, even though I define a function called SQR?
because
After
later
that, you have overwritten it
I
with
have
an.
overwritten it, exactly.
Yeah.
So those rules still apply,
Okay. Okay.
right? Those rules still apply. But what is nice is without any special. So actually, let me ask you this. I have to rush the later part a little bit, but if you want, let me show you how can I do something very powerful. Do you want to see how this map can be written? That means, oh, I can leave it as a homework. You tell me. Let me define a problem though. I have a list of values.
Mm-hmm.
I want to execute a function on every element in that list.
Mm-hmm.
But I don't tell you what the function is, right? It should work on any function. Let us call this new function I'm creating, let us call it map. Make sense?
Mm-hmm.
So for example, it looks like this, let's say. I want to def map. Map takes a list, any list, and a function. Right?
Mm-hmm.
And it has to evaluate this function on every element of the list and return a new list.
Mm-hmm.
How would we write this code?
Without for loop or with for loop?
We can write it with for loop also, okay? But let me write it with using list comprehension so you can see how powerful these ideas are, right? So I do here for I in a list. And then here I do a func I.
Off.
Okay, and I'm done. How's this?
Ah.
But what have I done? I've done some sophisticated programming, right? I've created a function that can work on any function. I can pass square or cube or anything into it.
Mm-hmm.
Right? So and then my code will look very nice, right? Because then I will just say map some list, right? L1 SQR. It look like this. Make sense?
Yes.
Or if I want to just print out all the values in a list, I would say something like this, right? I would say map L1 and I would just pass the print function. How is this? How many times have you written a for loop to print a function? To print a value. All over the place, right? You
Always.
map once and you're done. You never do this again. Make sense?
Yes.
Okay, so then the last part of this discussion is, yes, in order to do all this, I have to basically define SQR, right? somewhere I have to go and write SQR, and notice SQR is a one-line function, yes?
Yeah.
So once I get used to passing functions to other functions, it would be nice if I can define the function just where I need it. And that's what lambda is, right? Lambda is saying, make me a function. I don't even want to give it a name. If I want to give it a name, then I should use SQR like this and do def. If I don't want to give it a name, I just say lambda. I give the parameters and I write the logic for the function right there.
It's like in link queue.
It is like, what is this thing called now? It's an anonymous function in C#, right? Delegate.
Delegate. Yeah.
It's still called delegate, right?
Yes.
Yeah.
It's like we have lambda expressions.
Yeah,
and
you have lambda expression, correct. So Anders Helsberg, who architected C#, introduced lambda expressions in C# 2007. I'm not remembering exactly, somewhere there, 2006, 2007. Before link was done, they needed lambda expression.
Yes.
We can talk more about lambda. It's very powerful, but here you see it all coming together very nicely, right?
Yeah.
And since you said link queue, Pallavi, Pandas and all is like all link enabled, right? Using link kind of ideas here. Okay, so now a quick question. Will you guys finish this calculation?
Yeah.
Okay.
Will do.
Okay, try to do it and then just let me know, okay? So I think we're done today with series, okay? So do you guys understand what all we can do with series? We can create them, we can put all kinds of data in it, we can manipulate them. Okay, but series is also very flexible, right? So for example, I can take the heights as I showed you, the calculation power also is high, right? If I have heights, I can always calculate double the heights, for example. I can just do this, right? So it's very, 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 very easy. Or if I have heights and weights, for some reason, if I just want to add it, I can just add like this. You see all the element-wise operations, right? If you look up the index, it will match it. And here is, of course, integer index. First element getting added to first element. Notice that when I have this capability, my series object behaves like a spreadsheet, right? It's like two columns in a spreadsheet.
Yeah.
Just add all the cells in the spreadsheet together. This is the Pandas spreadsheet.
Then for squaring, can I do heights into heights?
Yeah.
Okay.
So let's try. Isn't that cool?
Awesome.
But of course, when it's squaring, it's actually taking the corresponding element and squaring it in place. Yeah, it's finding the first element and squaring it and putting it in the first location itself. So it keeps all the index gymnastics under control. So isn't this kind of code much better than writing loops all over the place?
It's much better.
Huh?
Yeah, it's much better.
Much better, right? And you have to start thinking like this though. So that's what I'm going to challenge you with, right? In the beginning, when you start this work, you're going to feel like, I want to, come on, man, don't waste my time. I want a for loop, right? Because you know that with a for loop and if statement, you can do anything. But the whole exercise here is, no, don't go there. Say what you want to do and let's find a clean way to do this, right? So the best way to practice that is to stop the for loop first. I put a tax on for loop. Every for loop you use, you have to tell me why. Okay. Make sense?
Yeah.
Okay. Keep trying and tell me, okay? Come back. I'm not saying that there is a friction here. I promise you there is a friction here. I'm trying to understand what prevents developers from going to think like this all the time, okay? I know that one reason is you have 20 years of practice or 15 years of practice doing things in a certain way, and now I'm saying do slightly different way. And we always want to fall back to our practice, right? So this is one of the reasons, but let me know whatever the friction is. Okay, now much more exciting than all this. So let's open the next notebook, okay? So open this Intro to Pandas notebook. So now I'm going to, this notebook is going to take a second to open, and then I want all of you to run this. This could take I don't know, it could take some time, this thing. If you try to run this first cell in this notebook, if all of you can open it and try to run this cell, it could take a little time. Oops. By the way, can all of you see the participant list?
Yeah.
No. Prakash, are you here? It said Prakash needed to be admitted. Okay.
Yeah, I'm back.
Did he just drop off or something?
Yeah. Power issues in
Okay.
Bangalore.
I just want to tell all of you guys, I don't know what's the best way. You guys are on WhatsApp and all that. For some reason, if you fall off and I didn't see it, just ping one of you guys. Yeah.
Connection is a bit sketchy. You can carry on, please.
Yeah. Uh,
I tried running. I got some error.
yeah. You can get some error. What does it say?
User warning. Matplotlib is building the
Yeah.
font.
Beautiful. That's just a standard. It's a warning. It's not an error. Can you just run it one more time and the warning will go away?
Okay.
Okay. So while all of you are running it, getting rid of those errors, let me tell you what we are trying to do now. So now we are taking this idea and we're going to the next step, which is we're saying, okay, one-dimensional data is fine. Usually we're working with tables, two-dimensional data, right? We have rows and we have columns and multiple columns. And I spend so much time on series because I'm trying to build up the thinking. Pandas has a way to do this. It's called a data frame. Okay, so now since all of you are experts on series, you should find it easy. So I have three lists here. I want to create a data frame. Okay. You want to tell me how we will create, how will we create this data frame? So let me say df1 pd dot, there's a data frame function here. What shall we pass to this? I want to create, so you can see there are three lists, right? So I would like to think of this as three columns.
A plus B plus C or A comma B comma C.
Okay, so it's commas. Okay, that's pretty close. It is A comma B comma C, but it has to be a list.
Okay.
Okay, so it's going to take a list of lists. That's it.
List of list. Okay.
For me. How does this look?
Nice.
Nice. Okay, that's just beginning, right? Notice that this guy comes with two default indexes. I should call it default indexes, but I will just tell. One is there's an index, which we are already experts on index right now. But now it's also column names.
And it auto converted the A list to float.
Yes, by default, right? So that again, we have to do as type if we want to do as type, okay? But notice there's an index and there's columns. So suppose I want to specify the columns to be capital ABC as my list names were, and I want the index to be small ABC for some reason. Then as we expected before, there's a way to do this, right? So if you look at this, now I got my data frame. Okay.
No commas also between ABC.
So now, okay. So I'm sorry. I'm going to be apologetic, but of course, I'm showing off my Python skills, right? So, okay. So let me say why I'm showing off. So ABC is a string, yes? If I pass it to the list constructor will split the string into A, B, and C and make a list for me.
Okay, characters it will make.
So if you don't want to do it the way I am doing it, you have to basically make a list and put A, B, C into there. Make sense?
Yes.
Please don't let me confuse you, okay? If it's too cool, then stop me and then I will write it the long way. Do you want me to write once the long way? Maybe I can.
No, it's okay. Got it.
No, I'm just saying that it's important, right? I mean, I'm using some tricks, but sometimes tricks can confuse you.
It's nice. It will help us know different ways. So.
Yeah. And of course, hopefully you agree my way is a little bit better than all this typing, yes? Which one looks better, this kind of thing or this kind of thing?
Obvious.
Obvious, right? Okay. No, I mean, honestly, when I ask the question, I don't expect you to agree with me, okay? Sometimes it's okay if you say, look, Vijay, that looks cool, but it's confusing to me.
No, that we have, like, last time you really tried to get us all on board with Python logic, but we are still a little unsure and sticking to SQL. So you don't worry.
Yes. So we're going there, but already today, I hope I did one step in convincing you.
Yeah, this is super.
No, what I did with series already is very, very powerful, right? Try to do all these operations.
DMLs can be like done so easily, like, with with
Yes.
series and
Yes. Yes. Sorry, can I just interrupt one thing? Okay. I just want to mention it now. We talk about it more over the next session also. I want all of you, in particular, I'm thinking of Sachin right now. If you can come up with some kind of problem that you do today at work with some ETL, right?
Okay.
Take some file, change it. Can you give some kind of requirement, right?
Sure,
I can
sure.
work with you, right?
Okay.
And let us try to, don't make it like a 2-month project, something reasonable.
Yeah,
So
something. Yeah. Fine. Yeah,
because
I'll
I
do
need,
that.
yeah. So, and you can discuss as a group, right? What would we like to do? We want to take this kind of data, do something low. Okay, so let's keep going. Okay, so I created the table now. Okay, let's not worry about reassigning indexes. I'm going to fast forward through this piece because we already know this, but we did this last time. So I'm going to use the same type of idea as we did before. So can all of you create a data frame out of this? But this time it's a little bit more clever. There's 2 columns of data now. There's population and there's area. Last time we only had population. So can you make a data frame from this?
okay. Mm,
When you finish, tell me. While you guys are typing, can I ask this question? I'm making you type a little. Is that a good thing or a bad thing?
it's good. We are getting
It's
a
good
hang of
actually.
it.
Yeah. Because
Typing is always good actually. That's why like you learn like to basically to you learn the syntax actually in a function.
yes. I want you to type a little. Otherwise, I tell everything fast, and then you're like, I don't remember anything, right? So I know it slows us down a little bit, but I think it's a good thing. So let me know.
Hmm. I got an error. Okay.
That's welcome to errors. You want to tell me what you're doing, Pallavi? I can also help.
Okay, maybe because I didn't run. Wait, not yet. no, 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 I got it.
All right. So tell me what you did.
I did df2 is equal to pd dot data frame of data, comma index is equal to cities. And I got 2 columns,
Yeah.
population and area.
Okay.
Yeah, that
Identify.
was the first I got.
That's okay. Yeah. And then.
Cities are data.
So what do you
Underscore.
think about this now? Very nice, right?
Super.
What is also nice with this Pandas notebook is that as a Python notebook is that when it comes out all nicely formatted like this and so on, it's pretty nice, right? I mean, it's nice to be able to see the
Visualize
data.
it. Yeah.
Okay, so now what? Okay, so we got the data into data frame. So let's spend a little time playing around with this guy. First thing is you can do all kinds of cool things with the index of this data frame, right? So let me show you an example here. I have.
What is the by default the sorting order it does? Because the result actually I can see on your screen is different to my screen.
No, the sorting order should be the order in which I specified.
No, yeah, it is different on my screen too. It is uh first is Puff Keep C, then New York City, then Buffalo.
Yeah,
It's
same actually I have, yeah, same order.
For the index,
Yes.
I'm puzzled. I don't
exactly
know.
same code. And
I've never seen
exactly
that,
same
but
code.
okay, let me just double check it, okay?
Mm-hmm.
I mean,
In my case, Puff Keep C is 85,000. Sorry, 850.
Yes, same Puffy is 85 and the NY is 25 and Buffalo is 32.
okay. First of all, I think there's a mistake here. That's why this should be a list. So can we all fix this?
Okay. Correct. Yeah, okay.
Fix this.
Oh, okay.
Yeah, now it is New York City, Buffalo, and Poughkeepsie.
Good, good.
Yes, now it's fine.
Yeah. I think that is quite important also, right? Because, okay, so we touched on a very important thing. When I use a flower bracket, it tries to make a dictionary for me, but dictionary doesn't guarantee order. And it's really cool
Okay.
that you guys got something different than me, so that it highlighted the problem. The point here though is this order is very important because my data is actually ordered, right?
True.
So when I'm specifying the cities away from there, and notice I cannot put the cities into this, otherwise I have to put some kind of nested dictionary and so on. We'll come to nested stuff afterwards. Okay. So anyway, so we have started, but I just want to give you quick examples. These index objects. So there is an index here. So why can we pull out the index and values for this guy quickly for cities data?
Okay.
Got it?
Yeah.
Yeah. So now I want to say that index is quite a powerful object. In particular, I just want to show you a little thing. You can do Boolean logic on index, right? So here, if I create a second data frame, which has slightly different index values, notice AB is matching and X is not matching. Then I can do Boolean logic. For example, I can AND the two indexes. Give me the common values between two data frames. Okay, or I can OR the two indexes and give me whatever's A or B, union of the two. Okay, so you can play around with this. So the index is, think of the index like you have the set operations, union, intersection, etc. Right? Okay, you can also reindex, right? So if you want to reindex, you can reindex like this. You say reindex and pass in a new list, okay? And notice that in this case, my list is longer than my data, and it's also going to work. Like create df2. Yeah. So if you want to reindex, you can reindex like that, okay? And if there are no matches, it will put NaN here. Okay, and you can
NaN
reindex
because of float, is it?
Huh?
Because it is float value data type, that is why it will put NaN.
Correct.
If it had string, it would put null.
Correct.
Or object. Okay.
Correct. Correct. It'll use the default for the thing.
Mm-hmm.
So here, I can also reindex the columns, right? So one way, if you want to add a blank column, is just to reindex and then pass. Notice here, instead of index here, columns is something is treated like an index, right? So I can always go to a data frame. So let's go back here. Data.value cities.index. Here I can say columns also. Right? You just say columns, dot columns, and we should see the column names.
Retrieving data?
From where?
Two values. Like if I want to retrieve one value,
Huh.
like
I love the question. Great question. Okay, so I think that's where I'm heading. So let's go, and just before I retrieve, let's just do one more thing here quickly. So let's go back here. The same cities data, you already created it, so you don't have to recreate, but just fix that flower bracket thing here. Okay, so the idea is this: so let me just recap the pattern. Get your data from somewhere. You have rows and columns, and you use those rows and columns data to create a data frame, right? Is that process clear to you? You will be able to create a data frame now with any kind of data.
Mm-hmm.
Okay, so once you've done it, the first thing we will want to do is we want to inspect the data. Right, you want to know what's in. Suppose I load it from a file or somewhere. I want to know what is in my data. You can of course print it out, but it may be a large output, right? So there are some simple methods we can use. For example, we can say cities data dot head, HEAD. That will tell me the top the starting 5 values or 10 values, right? If you want to see just the top of my data. So of course, in this case, it's not going to be very effective, right? But if it's a large data set, it'll give you top values. You can also say top 5 or top 10 or whatever, something you can say, okay? Whatever it is later. Similarly, for head, there's also tail, right? So you can see the last 10 values if you want. So usually those, when you get a data frame, that might be things you want to do. Then you can do things like this. You can say info, which is also a nice thing to do as soon as you get a data frame. If you say info, it will give you all the data about the data frame. Right? It tells you there's an index, these are entries, it goes New York City to Poughkeepsie, which are the columns, population, area, tells you that there are 3 non-null values. You get a lot of information from info. Make sense?
Mm-hmm.
And if you want to be more sophisticated, you can do describe. If you do describe, it will do a statistical analysis of your data. And it'll give you mean, median, mode, standard deviation, blah, 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 everything. Descriptive statistics.
Mm-hmm.
Okay. So I think info is most useful. Describe not always, but we can use both of them. Okay. So, okay. So now Pallavi's question. How do we select stuff? So since you're all series experts, what should the bracket operator do? What can the bracket operator do?
Mm-hmm.
We're going to use the bracket operator to get information back, right?
So bracket operator, if you pass index, you'll get like one entire column,
So
like
can you try something and tell me what you get?
okay.
I know we are just running out of time here, but can I take another 10 minutes extra? Is that okay? Are you guys tired?
My son's school is starting tomorrow, so
Okay,
I want
okay.
to end.
Okay, so let me just show you how to extract data and then we'll take this into the next one, next class.
Okay, sure.
Yeah.
I tried bracket operator and I got error.
Yeah, what did you put in the bracket operator?
I put New York City.
But what is my index?
Okay, error. Okay. That is the index for
Yes.
cities data.
Okay, so let's go back. Okay, we'll come back to this. So okay, so let me start with a simpler data set. Okay, so this data frame a df1. Let me see if it's defined right now. So let me start with df1. Okay, so df1 looks like this. Okay, and you should think of this as a collection, but the simplest thing you want to do is to get the columns, right? Does that make sense? The simplest thing we want to do is to get the columns from a two-dimensional data. So we'll do columns first, and then we'll do rows. Okay. So Pallavi, what you were trying to do is rows. Okay.
Correct.
Yeah, but let's do columns. And what would happen with columns right now? Let's do another one. I can specify a list of columns because there's more than one column. And when I'm specifying a list, I can give in any order I want. It's going to find it in the order, match it, and return it to me in the order that I ask for. So I can say A, comma, C, okay? And I'm going to get all the columns. Oops. My bracket is on. Okay? So retrieving my column is easy. It's probably the standard pattern, right? If you have a cell, you might want to do operations by column. You also want to do operations by row, okay? So, so let us try to do by row, okay? But for row, there is this idea which we have. How do we want to specify the row, okay? So here we'll df1 dot, and I want to use the index, okay? So what is my index here? It's little a, right? and then I get all the columns for that row.
Okay.
Okay, because why? If I take off this lock here, he has already given me the default access to columns with just a bare index operator. So if I want a row, I have to specify lock. Make sense?
Okay.
So what? Okay, so now do you think slices will work?
Has to.
Very cool, right? Now that we're experts in slices, we can do all these cool things. Okay. What else do we want? So that's basically what I wanted to say to you. So maybe we'll stop here. We'll spend more time on slices and so on next time. I just want to give you a preview of where I want to go. What I want to do here is I want to show you how to use more operations on this. And if you want, you can even look ahead and ask me questions. But next time I will spend a chunk of time on data frames. Okay. Let me just tell you that at the end of this, after we learn how to manipulate a data frame, I pulled one data set in here. Okay. And let me just, okay, first of all, okay, you guys can tell me this. I put this in because you guys were all telling me about SQL. So let me just show you this quickly, okay? Maybe you can play with this. So I took the same SQL database and I took the data from SQL. I wrote some, Sachin can tell more about my cute little functions, okay? I wrote one cute little function, but notice this. I do this and it actually gets me the data in a data frame now. Make sense? So I'm taking the data and I'm pulling it from the database and I put it in a data frame. But what does that mean? I can do very powerful things. For example, if I get two data frames, so I have the courses data and I have the students data. I want to join them, right? So I'll take all this data. I've taken all the data from the tables in SQL and I'm going to join them in Pandas. This is called merge. So I can say pandas.merge and I can give two data sets.
Denormalized. Wow.
Denormalized, and I can do join and I can specify the key to join on. By the way, it's even clever. If I don't specify the key, it'll go and look for a matching key and try to help me.
And if the key names are different, then also we can give two names.
Then you specify the left key and the right key.
Okay.
Okay, if the column names are different, like ID student is called ID students or something else there, student ID, you can say left key is this and right key is this. Okay,
nice.
But what do you think about this now? Am I competing with SQL or what?
Yes.
Okay, I'm not done. I'm only starting. Right?
Nice.
Okay. So maybe this section you can play with. Just this section which says in your notebook you should have this section which says combining data frames, merge and join. Just learn these two functions, merge and join. Okay. The full SQL capability is here. Join, inner join, outer join, left join, right join. Everything is here. Okay. So just try it and see. Okay, and then give me your comments next time. I'm still writing SQL, Vijay. What's going on? Okay, and I'll keep building out this example. Let me ask you quickly: is it good to use this example and try to do these things in Pandas?
Yeah, this clearly brings it out. What you are saying, like how Python can be powerful. So yeah.
Yes, and we'll do more like this, right? So when you want to actually do calculations, you can see where we start having trouble with SQL. If I give you a complicated calculation on student data, calculate the average of grades this way, that way, and then do something complicated, it will be hard to write all that in SQL. Okay, eventually I will start creating examples which you will just give up and say, I can't do it in SQL. Right now I'm still getting competing. Okay, we are done for today. Sorry, it took a little longer than I thought, but I think we covered some good stuff. Let me just quickly ask all of you, what did you think?
Very interesting.
Yeah.
Interesting.
Cool.
Okay.
Interesting. Yeah.
Yes, I think, of course, it'll take a little time for you to fully absorb and appreciate this, right? But I'm showing you how do we get more and more powerful in the things that you've been doing for a long time, right?
So, Vijay, one question.
Yeah.
So, have you done any comparative analysis of how Python is more I mean, from the performance perspective, we can use these functions, and it will be more better to use Python than the SQL.
So here's the important thing, right? As we discussed before, first of all, there are two things in this Python versus SQL that we must understand. The first thing is SQL becomes hard to do certain analytical calculations. Right? Remember how I told you calculate body mass index, that problem that we had. If you try to do this, just imagine, right? I have a database with lots of people and I have to calculate this. You can try to write some SQL function, blah, 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 but eventually it will become very, very clunky inside the database. To write code like this inside the database will be very hard because SQL is not meant for that, right? SQL is meant for doing set-like operations. It's not meant for doing analytical calculations. So people have tried to solve that problem. Oh, Pallavi, I'll let you go. Bye. Bye.
Thank you.
Yeah. Bye. So people have tried to solve that problem by creating certain add-ons to SQL databases where you can put Java or C++ or something and then try to call it. So if you go down this path of SQL plus some augmented thing, you're going to find eventually that the database has two roles to do. One is it's the place where we store and retrieve all our data. And if we make it the place where we do all our computations, the database will have conflict, right? It has only finite amount of resources and it will try to do calculations and store data. So then people who are trying to write to the database will get slowed down more and more because the database is busy doing all this calculations.
Yeah.
And so in a large scaling situation, when you have if you have a big powerful Oracle database and you have 100 customers, that's okay. But if you're like Amazon and you have 1 billion customers and you start doing all the calculations on the database server, that server will just get killed.
Yeah.
Right? So the idea which we have come up with is a different idea, which is you must take the calculations out of the database. And of course, the calculation server also will get killed eventually, right? If I put a lot of calculations on one server, it will get killed. But that's okay. I can buy a second server. Right? But it's not simple to have two database servers because then you have to keep the data in sync. Then you have to write to two databases and so on, right? So it is a very detailed scaling question that eventually when the trouble comes, your database is primary benefit of a database is to store and version and keep the data good. Okay. If you try to put too many calculations there, you're going to have problems. So that is the first point. The second point is certain data is not even in the database, right? So then what will we do? For example, I have some files with data in it. Every day I get some files. This is Sachin's headache, right? Every day some file is coming. Then you have to put a whole ETL process to take the file and push it into the database so that I can do something with it, right? Yeah. But here we say, if you don't need it in the database, it's coming in files, I can just load it, do the calculation and put the value add into the database if I want. So I can process non-database information.
Got it.
Right? And in particular today, this is a little bit beyond what we need in companies. But for example, there's a lot of data on web pages, right?
Yeah.
So I want to do some analysis on web page data. So then I can use program to go and get the data. So there's some nice examples like this. You can go to Cricinfo and using Cricinfo, you can scrape all the statistics of players, right? So you see, if I try to do all this kind of work, how will I do with the database? It's sitting on a web page. I can't even get it into the database.
Yeah.
Another great example is companies want to use, for example, Twitter information, right? They want to go to Twitter and they want to see whether there are positive tweets or negative tweets on the company's product or company's name or something, right? So now the Twitter data is not a database data at all. It's a bunch of tweets. Can be thousands and hundreds of thousands of them. Then again, same problem. How do I get all these tweets and put in a database? And what's the point of putting tweets in a database anyway? I don't need to version this data. It's just a big...
Yeah, we just keep that analysis.
Correct.
Outcome.
So you see, I'm giving you hints as to there are all these places where it's unclear why we're putting everything in the database. Just to do a calculation, I can just do it quickly on the side or whatever it is, right?
Yeah.
So I think the correct answer, and of course, we haven't even touched on this, but I'm sure you guys must be aware of this. There's an entire movement called the NoSQL movement, right?
Yeah.
Have you spent any time looking at what they're saying?
Not yet.
Okay, so shall I take a minute and tell you some points from there quickly?
Yeah, sure.
Yeah, so the whole NoSQL, of course, if you just read the words, it says NoSQL means don't use SQL. No, that's not what they're trying to do. They're saying not only SQL, right? That means there are things that SQL can do. Let us try to use SQL for that. But there are many things that don't look like SQL at all. Then we need other kinds of solutions, right? So for example, if you have a file, it doesn't look like a database at all.
Mhm.
What is the advantage of taking a file and putting it in a table in a database? The database is not doing anything. I'm not using the index because every time I have to do work, I have to read the whole table. Then I'm going to calculate something on the whole table. I'm not getting any benefit of the database itself. So maybe the file should just be a file, and then I just read from the file, I do my work, and I close the file. Why do I need to put it into a database, right? Or better example is all this JSON stuff. There are web services, they vend data. Data comes back as a dictionary, as a Python dictionary. So now why will I take a Python dictionary and convert it into a database table? I can just do my work and be done, right? So these are all discussions. And so people have created all this stuff. They're even saying, okay, if I want to keep the dictionary and I want to save it and I want to retrieve it with queries, so that's why they created databases like MongoDB, right? Document databases. You can take the whole JSON structure and put it in a database. It's just not a SQL database or a relational database, right? So there are all kinds of other ideas that are branched away from the conventional monolithic big fat database story. And these are all trying to be small agile solutions, right? I want to grow, I want to start with some structure, then I want to add more and more customers, and I want to be able to grow. You just, as I grow, I get more money, I will put more and more machines. So in those settings, if a good example, maybe, I don't know, do you guys have seen something like Reddit or something like this? Reddit could be a good example. There are thousands and thousands of posts on Reddit. So if I try to put all the Reddit posts in a database, it's going to be a headache, right? This database gets so big, what will I do? So you can break it up, you can save it in files, every post can be a separate file, you can do all kinds of stuff without a database. Right? Yeah. So I think we are there. We are in this world of no SQL, not only SQL, right? And our job is to find out the strengths and weaknesses of different approaches. Right? Of why would I do it this way versus that way, right? And I don't think the answer should be just, I know SQL, I'll put everything in SQL. That's not a good answer. The answer should be, where SQL is giving me true value, then let's use it, right? And I think the places where it's giving, if you ask me, the places where it's giving true value is when we have denormalized versioned data, right? It's very granular, multiple tables, the tables are changing all the time. This is nice to put into SQL. But everything else, like when people are doing all this, sorry, I said denormalized, I meant normalized version data, okay? Multiple tables and versions. But if I have denormalized flat data, then even a file is enough. You put the data on the file and put it in a file. Why do I need the database? Nothing at all, right?
Yeah.
Yeah. So we didn't do any file IO yet, but okay, when we do it, I'll show you with Pandas as well. Pandas has one line command, read CSV, and all the data is in a data frame already. Right? So there's no reason to put it in a database. Also, I'm showing you with Pandas that if the data is in a database, that's also fine. We can pull it back and work with it. And then the last piece is, remember when we started this, we started saying data science. And data science means that I want to take all the data and then I want to ask all these questions, right? What is the mean of the population? What is the average of the population? What is the density of the population? Blah, blah, blah. I want to ask all kinds of questions to the data. Then that data better be close to me, not in some database server. Because if I have 10 or 15 database scientists, all of them are querying the database and running all the calculations on the database, we will definitely have problems. Right? So I think you guys might have had already something, right? Isn't there some rules from the database admin saying don't run big processes on the database or no?
Yes, we have.
Yeah, we do.
Not the rule set by the DBA actually. You cannot actually, the query should not run more than this time. Then you will not get this much of rows.
Yes. Yes. See, those are all the problems, right? The true problems, and very hard to manage. Both sides, right? DBA also is having problem because sometimes in Sybase I used to have, I don't know if they've still fixed it in SQL Server or not. They used to have this thing called tempdb, right? And whenever you want to do anything in SQL, one of the data structures is to create temporary tables, right? So one of the problems we would have is TempDB would get full. They will allocate some space for TempDB. Eventually, everybody's creating temp tables. The weird problem was you don't know who is filling up TempDB,
Yeah, that's the main
right?
problem.
Yeah. So what are you gonna do? You have a big, big production database, and suddenly TempDB is full. Everything will just die,
Yeah.
right? So those are all huge. Even transaction locks, right? If you're writing a lot to the database, if multiple people start writing, you can start blocking each other, and you create huge problems on the database, right? So there is a tremendous cost to it, and that's why I'm saying we must understand the true power of databases, and use it for its true power. But if you start doing all this other stuff on the database, it will definitely just die. So maybe I'm just giving voice to all the problems you've already seen, right? MDB full, blocking tables,
Yeah.
timeout on connections, right? All this.
Station mails from DBAs.
Yes. So the DBAs are not very happy with this because it means little job security loss for them. But if you're a smart DBA, you learn all these things, right? So that you can be part of this revolution too. You don't want to be just living on old stuff, right? I mean, there's nothing new happening. You want to pick up some new ideas. And of course, I'm going to show you more, right? I mean, after we get all this data, start massaging, I'll show you how we can visualize. You want to make charts, you want to make reports, you want to do all this stuff. How will I make all this on the database? Not possible, right? You can try. By the way, I cannot tell you guys how many years and hours I've spent on OLAP cubes and reporting databases and data warehouses and all this stuff. I can share a lot of interesting experiences from that. Right. Only thing I can say is there are tools. You must know the strengths and weakness.
So are people building tools on top of Python to just for the data management? Do you know any tools available?
Yes, of course. That's the new wave. Yes.
Like we have all the ETL tools, right?
Yeah. So this is something we should discuss because some of you are thinking ETL. Sachin's working on ETL. I don't know because I think the ETL developer is living in a small cocoon, right? He's living inside an enterprise. He's not exposed to any of these ideas. He learned a certain tool set, whatever that tool set is, right? Informatica, whatever tool set he's using, SQL, ETL, whatever. What is it called? SSIS or whatever. I don't even know. Is it what it's called? SSIS, yeah.
Yeah, SSIS.
And they just learned that tool set 10 years ago, 15 years ago, and they just keep on working on it, right? The question is the world is changing around them, right? And maybe, like still we have COBOL programmers, right? So I don't know whether SSIS job security is gone, but I think there's more fun here, right? For sure, if I'm an SSIS developer, I will do my SSIS work, but I will learn all these ideas, right? So tomorrow if I need it, and then I want you guys as ETL or database people to say, yes, I could use this. Here's what else I would need.
So what do you recommend for, as a reference for Python, whatever you have taught us, we can go into the Jupyter and we can run it. But you want to reference some online books or something, what do you recommend? I'll make a small list. Can you do me one big help? Okay.
Try to send me a quick email.
Okay.
And give me 1 or 2 bullet points of the kind of things you would want.
Mm-hmm.
Right? Books that would show me this kind of things, whether it's Python syntax or programming examples or whatever. Just give me some bullet points of what would be useful to you. Then I will try to tell you if I can find something like this. Okay.
Yeah.
By the way, I want to share with you guys this, right? I'm saying that because this is an ocean, and it's an ocean you can get lost into. That's the only reason why I'm telling all of you that the best way to learn is we work together on it, right? Once in a way you can find a book, but I promise you're going to find these books tire you out. Because they will just, I don't know, you've tried to read any of these books, but these books are big and fat. They're all 600, 800 pages, and they will tire you out.
Hey, we just sorry to interrupt you actually, but I need to leave actually.
Yeah, all of us need to leave. So let's wind up. Let's wind up. Prakash, send me the email if you all of you want anything from books or anything. Just send me what you're looking for, and I will send it.
Yeah, definitely.
Okay. Thank you, guys. We'll talk to you next weekend.
Thank you.
Thank
Bye bye.
Yeah. Send me email with any questions. Okay.
Sure,
Yeah.
sure.
Yeah. Okay.
Bye-bye.
Bye.
Bye. Bye.